In this video, I will be going over the last of the questions for the study guide. So Unit 9, question 18. In a right triangle shown in the diagram below, what is the value of x to the nearest whole number? So because we have a right triangle, we can use our sine, cosine, or tangent ratios that are only for right triangles. So some old hippie caught another hippie tripping on algebra. So we'll pick one of those ratios based on our triangle. So 30 is our theta angle, and we'll label our triangle. The hypotenuse is probably the easiest to first label because you know it's opposite the 90-degree angle. We typically label opposite next, but there's nothing here that we know, and there's nothing here we need to know. So yes, it's the opposite side, but I'm not going to label it because really it's the adjacent that I need. So adjacent hypotenuse, we see that cosine is adjacent hypotenuse. So that's the one we will use to set up and solve. So cosine of your angle, it's always cosine of the theta, equals adjacent over hypotenuse. And now we will solve. You always multiply by the denominator. So whatever is in the denominator here, so times 24 on both sides. Once that variable is by itself, we're ready to type in the calculator. So x is going to equal 24 times cosine of 30. Before working with your calculator, make sure you check the mode. It needs to be in degree mode. So arrow down and over and select degree. So 24 cosine of 30. And it says nearest whole number, so that would be 21. That 7 would make it round up. And we have no units of measurement. We don't know if it's in feet, inches, yards, so we'll just leave it as 21. Be careful to know it's not 21 degrees. We were not solving for an angle. We're solving for a side. Let's look at the next one. We're going to solve each triangle for part A and B. As shown in the diagram below, a building casts a 72-foot shadow on the ground when the angle of elevation of the sun is 40 degrees. How tall is the building to the nearest foot? So again, we say a right triangle, so we're going to choose either our sine, so some old hippie, cosine, caught another hippie, tangent is tripping on algebra. So we're going to pick one of those ratios to solve for. It's wanting the height of the building, so that is our unknown. So of course the 40 is our theta angle. It is probably easiest to label the hypotenuse first, but I don't know the hypotenuse. I don't need to know the hypotenuse, so I'm actually going to just label opposite and adjacent. The side opposite the angle, the side adjacent to the angle. If you want to label a hypotenuse, you can. It's just not necessary to use in this problem. We can see with opposite and adjacent, that is going to be the tangent ratio. So we'll set up tangent of 40. It's always sine, cosine, and tangent of your angle. So tangent of 40 equals opposite over adjacent. And now we solve. Again, we're going to multiply by the denominator, so times 72. And our variable is by itself, so we're now able to type in our calculator. 72 tangent of 40, and we are rounding to the nearest foot for this problem, so that would be 60 feet for the height of the building. Let's look at part B. Again, it's a right triangle, so we'll either use sine, some old hippie, cosine, caught another hippie, and then tangent, tripping on algebra. Either our sine, cosine, or tangent ratio. So we have an 8-foot rope tied from the top of a pole to a stake in the ground, as shown in the diagram. So we see our picture there. If the rope is forms a 57-degree angle with the ground, what is the height of the pole to the nearest 1/10 of a foot? So we're finding this height of the pole. We have our theta angle, we have our hypotenuse, and we're solving for the opposite side. So label your triangles so that you know what ratio to use. Opposite and hypotenuse, that will be the sine ratio. So sine of 57 equals x over 8. Sine equals opposite over hypotenuse. And now we solve by multiplying by 8 on both sides. So x is going to give us 8 sine of 57, rounding to the nearest 1/10 of a foot this time. So the tenths is 1 decimal place, so 6.7 feet. Question number 20. We're going to write 3 different equations that could be used to solve for angle D. So in order to solve for an angle, you would use inverse. So we could write inverse sine, inverse cosine, and inverse tangent because we actually have all 3 sides. So let's label them first. D is our theta angle. The 13 is the hypotenuse. The opposite side is the 12. And then the adjacent side, the 5. So still sine, cosine, and tangent for our ratios, but we can set them up this time now as inverse so that we could actually solve for the angle. So angle D, inverse sine, so sine to the -1 is opposite over hypotenuse. So the opposite side is 12, hypotenuse is 13. We could use that to solve for angle D. But it does want 3 different equations, so we'll actually write the inverse cosine and the inverse tangent as well. So angle D, if we use inverse cosine, that's adjacent in hypotenuse, so 5 and 13. And then finally for the inverse tangent, opposite and adjacent, so 12 and 5. Because we have set up all 3, we could check them in the calculator to see that they're all equal. So inverse sine, you press second and then the sine button. So we have 12 over 13. Inverse cosine and inverse tangent. And actually notice they are all equal. Let's look now at question 21. We're asked to find side BC, but notice what you're given. You're given an angle and you're giving adjacent sides. We cannot use right triangle trig, the sine, cosine, and tangent ratios, but we can use either law of sines or law of cosines. Based on what you're given the adjacents, that should tell you cosine, because cosine stands for adjacent in those right triangle trig, so it helps us know to use law of cosine for this one. So the law of cosine starts like Pythagorean theorem. A squared plus b squared equals c squared. The last part of it is minus 2ab cosine of c. So let's plug in our numbers. The a and b don't matter, so I'm going to choose 30 for my a, 21 for my b, And then we'll do it again. 30 and 21. Cosine is your angle, so cosine of 123. Or 123. We are going to use that to solve for c squared. So once we type all this in our calculator, we have to be careful that we need to find c, not c squared. So we'll end up taking the square root. Let's do that now. So 30 squared plus 21 squared minus 2 times 30 times 21. And then we want cosine of 123. So all of that gives us 2027 point some more. We actually want to take the square root of that number. So we get 45. So c squared equals 2027 point, we'll say 25 when we rounded it. So c ends up equaling 45. And we'll just round that to the nearest.
Good morning, teachers. Just a quick announcement. If you have an appointment between now and 10 o'clock with the insurance company, those will be delayed due to the representatives having to go to the bus garage. So appointments will begin after 10 this morning. Everybody have a great day.
So now let's look at question number 22. We need to find the side HF. So HF is here. Notice again what you're given. Yes, we're finding that side that's opposite of the given angle 124, but the given information where we know all is the angle and this side opposite. So our given information lets us know what to use. This one we'll use law of sines because we're given an angle and a side opposite. So that gives us law of sines because sine means opposite. So law of sine is sine of our, let's actually write it up here. Sine of our angle to the opposite side. Again, sine of the angle to the opposite side. So let's set that up. Sine of 28, and our opposite side is 37. And then we have sine of 124. And our opposite side is what we're solving for. So we will cross multiply to solve because this is a proportion. So g sine of 28 is going to equal 37 sine of 124. Divide by sine of 28 on both sides. We're doing that because we're trying to get g by itself, move things away from the variable. So g equals, now that we have our variable by itself, we can type in the calculator. So one way to do this is you can use alpha y equals, or I really like to just say 37 sine of 124, press enter so you're telling the calculator that's a group together. Then I want to divide by sine of 28. So you can do it that way, piece by piece, or alpha y equals, and just type it all in at once. 37 sine of 124, divide that by sine of 28. And notice they do give you the same, so whatever you prefer. It doesn't say how to round, so I'll just go ahead and do to the nearest hundredth, so 65.34. Now for question number 23. We want to write the specific volume formula for the shape and then find the volume of that figure. So this is a cylinder. So it's going to be the volume of the base area. So our base is a circle, so we'll have pi r squared because that's the area formula of the circle. And then because we're three-dimensional, we have to say times height. So let's use this formula to calculate our volume. So volume is going to be pi. For the radius, we're going to have to take 12 and divide it by 2. 12 is the diameter, And the radius, we only need half of that. We only need from the outer edge to the center for our radius. So we'll take 12 and divide it by 2, which is 6. And then of course we'll multiply by the height. So let's calculate that volume. The pi button, you'll hit second, and then it's right above this caret key below your clear button. So second pi. Then we want to take 12 divided by 2, or just type in 6 squared times 13. 1,470. And we'll go ahead and round just to the nearest tenth, so 0.27. 1470.27. We are in feet for this problem, so that's going to be cubic feet. Because it's three-dimensional, we need cubic units. Question number 24. We're going to write the specific volume formula for the given shape, and again use that to find the volume of the figure. So this is a triangular prism. Triangular because that's the shape of the base. We know that because they're parallel to one another. And it is a prism because they have the parallel bases. Remember, a pyramid would come to a point. These being parallel to one another cause it to be a prism. So that volume formula is going to be area of the base. So we have 1/2 base times height. That's the area formula for a triangle. And then we're going to make three-dimensional times the height of the figure. So let's focus in on just that triangle. So we see those numbers labeled here for the triangle, but also notice there is a number over here. However, we're not going to need this number. We need the base and the height. To find the base and the height, they must meet at that 90 degrees as it does here. The 4 and the 7 will be our base and height numbers because they meet at the 90 degrees. You end up not needing this 7.3 because it's not the base of the triangle, it's not the height of the triangle. It's unused information. So 1/2 times 4 times 7, because they meet at that 90 degrees, they're our base and our height, times the height of the figure. The height of the figure will go from shape to shape. So in this one, being a triangular, goes from triangle to triangle. So that 10 is the height of the figure. So we can calculate that volume. 1/2 times 4 times 7 times 10. That gives us a volume of 140 cubic inches. 140 cubic inches. And finally, for our last one here, we're going to write the specific volume formula for the given shape. Then, of course, use that to find the volume of the figure. So this is a pyramid, so we will need to start with the 1/3. A volume of the pyramid is 1/3 the volume of its prism. So 1/3, because it is a pyramid. Look at the base. That is a rectangle, so we'll need length times width, and then we'll multiply it times the height of that pyramid to make it three-dimensional. So let's plug in our numbers. 1/3 times length and width will be 16 and 8. Times the height of the pyramid, we have the 6. So calculating that, 1/3 times 16 times 8 times 6. I did not hit 16. There we go. So 1/3 times 16 times 8 times 6 gives us 256 cubic inches.